Okay, this is section 4.11, uniform linear motion. Alrighty. Okay, just so you all know, I have a tube up my nose that goes down then into my stomach. It's called an NG tube. And so talking's not the best thing. And you might kind of hear the suction they're doing on that. But at any rate, so, just as we did earlier, you would get like an X and then some A plus BT, right? We just had somebody moving in say a horizontal line, and their X value would be based on a starting position here, time, and their rate of change here. Okay. Well, now, if somebody is heading off this direction on a XY coordinate system, we need to describe both the X and the Y. And so it gets a little bit more complicated. So what we'll have is that X is equal to some A plus BT, and we'll have Y is equal to some C plus DT. And now we have four things we don't know, right? We don't know A, B, C, or D. And generally speaking, what we need are four relationships or four equations to find them all. Now, in this, they're given to us in a pretty nice way. So we'll get two relationships, usually. Two relationships at t equals 0. Okay, one for x. We'll be told x is equal to some x0. We'll be given that value. And we'll be told y is equal to some y0. We'll be given that value. So what we'll get from that is if we substitute t equals 0 into these two equations here, we'll get that a plus 0, so a is equal to x0, whatever that starting point is, and c is equal to y0, whatever that starting point is. Okay, so that'll be nice. And then two more relationships. Okay, we'll get two more relationships at another time. Okay, let's call it T1 or something. And what will happen there is, well, we'll know what A is and we'll know what C is. And so, if I write that A plus BT is equal to X, well, we'll be given an X1, a new position. So what will happen is we'll know the value of A. We don't know the value of B, but we know the value of T. We'll know the value of X. And again, A we'll know. And so B is going to end up being X1 minus A over T1. Similarly with C, plus T equals Y. Well, we'll not know D, but we'll know our time 1. We'll know the position at time 1. We'll have already found C. And so, D is Y1 minus C over T1. Okay, so that's what's going to happen. Well, we'll get alrighty. There we go. So let's take a look at their examples. They have example 411.1, and so what they have is Bob runs from point 2.3 to the point 5 minus 4 in 6 seconds. Okay, now it says find his equation of motion. Well, you know, the interesting thing here is they don't tell me what units those are, so I don't know. But we start at 2.3, so see, that's the x0, y0 is 2.3. And so if we take a plus b times 0, so we assume at t equals 0. So if we take a plus b times 0, we're supposed to get 2. And if we take c plus d times 0, we're supposed to get 3. Well, that tells me a equals 2, c equals 3. So that wasn't bad. And then after that, we've got our 6 seconds. So at t equals 6 seconds, what we have is that our A, so 2 plus B times 6 is equal to 5. Okay, that's our position up here, 5. And then 3 plus D times 6 is equal to negative 4. And so we can use these to find B and D. So I have 6B equals 5 minus 2, or 3. And so B equals 1/2. And similarly, we have 6D is equal to negative 4 minus 3, or that's negative 7. And so D is equal to negative 7 over 6. And so we put those together, and we would have X is equal to 1/2 T plus 2, and then Y is equal to negative 7/6 T plus 3. And so there are our equations of motion. Let's see, and I guess that's all they ask us to do. Now, you know, I could find this position at t equals 3 seconds, you know, so at t equals 3 seconds, X is equal to 1/2 times 3 plus 2. So that is 3/2 plus 2, which is 4/2, so that'd be 7/2. And y is -7/6 times 3 plus 3. And so that's -7/2 plus 3. 3 is 6/2, so I get -1/2. And so my position at time t equal 3 is 7/2 and -1/2. Okay. So there's that example. And now we also have example 4.11.2. And the difference here is that they actually do give us the units for the x and so forth. But they give us the direction to start with and a speed of 7 meters per second, heading away from the y-axis. So what are the equations of motion? Okay, so what they tell us is we have x and y, and we start at 3,5, and we have a line that is y equal -1/3 x plus 6. Okay, and we're told that Olga takes off heading away from the y-axis. Oh, okay, I was thinking x-axis, but the y-axis. So she's heading this direction. And what we want to do is figure out the equations of motion in this case. Well, once again, we need 2 points. Well, we've got 1 point, right? We've got this point is 3,5, and that's at time 0. Okay, so I can get started. I can say, well, I've got x equals a plus bt, and y equals c plus dt. And I'm told that a plus 0, or b times 0, is equal to 3, because that's the original x position. And c plus 0 is equal to 5, and so I know that a is equal to 3 and c is equal to 5. Okay, so I can get that the same way I got it in the last example. But now it gets a little tougher in that before, what I need is a time. And, well, they didn't give me a time. They gave me a rate. Okay. And so we need to come up with a way to get the time in a position based on the rate in this direction. Well, so it's a multiple process. So first we need a point, right? We need a, I guess it's like we. Okay, well, oh, come on. There we go. All right, we need a point. After t equals 0. So some other point. Well, you know, they give us this line, and so we could you know, pick any other point. Now they happen to pick a point of 6, 4. I'm not going to use that point, okay, because I think that's harder than I need to make it. But they pick a point 6, 4. Now, how did they get that? Hey, yeah, let me put this on pause. Okay, so yeah, we need a point after t0, and they came up with 6, 4, and they got that just by saying, well, let x equal 6, and then y equals negative 1/3 times 6 plus 6. So they got a negative 2 plus 6, which was 4. So that's where they got it. That's fine. But me, actually, I kind of like using zeros. And so I think I'd like to find this point here where y equals 0, that x-intercept. And if that's the case, then I've got 0 equals negative 1/3 x plus 6. So I have 1/3 x equals 6. Multiply both sides by 3, and x equals 18. But y equals 0. So this is the point 18 and 0. You know, it doesn't really matter, so you can look at the text and their calculations for 6 and negative 4. I'll do the similar calculations for the point 18 and 0. Okay, so we have our point. So we needed our 2 points, 2 x and y points. So we've got those just like we had in the first example. But now we need our time. Okay, so time, well, it goes back to their thing of time is distance over rate. And so we'll get a distance. Our distance between the 2 points is the square root of, we had our 18 minus, what was that, 3 squared, and then plus 0 minus 5 squared. And so that's, well, I'll do it down here. So that's equal to 15 squared, square root of 15 squared plus 5 squared. So that's the square root of 225 plus 25, the square root of 250. Okay, and again, you know, actually we did that at some point, the square root of 250. Here, I'm going to look it up real quick. So sorry, I got to take a minute here to look up the calculation. Well, I mean, I'm going to do the calculation, I guess. So I need the square root of 250. And that is 15.81 meters. Okay, so there's our distance. And then, so our time is our 15.81 meters over 7 meters per second, I think it was. Let's go back here. Oh, I don't think I ever wrote it down. Okay, well, if you're looking along in the book, yes, it was 7 meters per second, and so this becomes 15.81 over 7 seconds, and so that is 2.2587, so I'll call it 2.26 seconds. Okay, so then we have our time, and we do things the same way. We need to solve for B, so we had A, which was 3, and C was 5. So A, and then plus B times our T, 2.26, and that equals our position, which was 18, right? Go back here, and that was our point, 18, 0. So we have that. And so in this case, B times 2.26 is equal to 15. B equals 15 over 2.26. And so B is, let me get it here, 15 divided by 2.26, and that's 6.637. And let me look here. We should get the same value of B they got, and they write 6.640. That's rounding. Those are rounding issues. So yeah, we match them on B, and then we have forgotten the 5 for C there. So we had 5 plus D times the same time, 2.26, and we ended up at Y equals 0. So D times 2.26 is equal to -5, and D is -5 over 2.26, which is negative, and should be near -2.21. What do we get? -5 divided by 2.26. Yep, we get -2.21. We'll call this one up here 6.64. We'll just stop it there, and that both to that number of decimal places is exactly what your textbook got, using a different x and y value, but the same technique. And so our equations of motion are that x is equal to 3 plus 6.64t, and y is equal to 5 minus 2.21t. And we can see that, x is getting bigger as time gets bigger, and y is getting smaller. And when we look at our original picture, yep, that's what happens. So, that's another way to kind of check your work, is that, as we're moving in this direction, x is getting bigger and y is getting smaller. All right, so there is section 4.11.